So let's rewrite this equation in standard form. So it's number 2. Put rewrite in vertex form. And here's the equation. I'm gonna put it in standard form. I'm gonna throw it to you in standard form. Y equals x squared. Let's try it again. Y equals x squared minus 6x plus 11. Okay. So right now it's in standard form. Let's get this equation into vertex form. Remember, this is the first lesson that you'll see on the final exam in 3.5 weeks from now. We already did test 1 last Friday. Test 2 is your final 3.5 weeks from now with a few quizzes in between. And we're done. First step, I'll write in red. Right, but before that, which we haven't really encountered, make sure A is 1. So I'm going to write make sure. I'll put those steps in bullet. Make sure A is 1. Just like completing the square. Okay? And here it is, so we're good. No biggie. Second step. Add B over 2 to both sides. B over 2 squared. To both sides. Or, here's a little logical move that I'm going to throw at you that might scare some of you, but if you just think logically what I'm talking about, it makes life a little more easier. So you can add B over 2 squared to both sides, or a positive and negative. Positive and negative B over 2 squared to both sides. To just the right side. Just to the right side, not the both sides. And here's what I'm talking about. Watch. I'm going to give you a little option here. This little second option I didn't mention yesterday, because some of you will understand my logic of the math and maybe like this option. But if it scares you, just do the first part of the second bullet. But I don't think it'll scare you. Just follow me on this trail, this thinking trail, and it makes sense. Watch. Let's add B over 2 squared to both sides. So over here, let me calculate B over 2 squared. There we go. So let's see, B over 2 squared. That'll be negative 6 over 2 squared. And that'll be, let's see, negative 3 squared, positive 9. So look what I'm going to do now. I'm going to add positive 9 to both sides. But look at what I'm going to do. I'm also going to subtract 9 to the right side. In other words, instead of adding 9 to both sides, I'm going to add 9 and subtract 9 to the right side. Because what is it? If I add and subtract 9, what does that do? It cancels. So remember what I said a couple weeks ago, an equation is like a balance. If I add 9 and subtract 9 to the right side, the equation doesn't move. Look, I'm going to add and subtract 9. It stays neutral. The way I taught, look at right here where it says the second bullet, if I add B over 2 squared to both sides, I'll put a plus 9 over here. But then in the end, I'll still have to subtract 9 in the end, and that's what this is. So why add 9 to both sides when in the end you're going to get y by itself and have to subtract in the end? So this is doing it one shot. Add 9, subtract 9, and that cancels each other out. But the beauty here is we're manipulating this equation. We're manipulating it logically to get the equation to look a certain way for us. Total manipulation. Like when you do that to a human being, you manipulate a human being so they can behave a certain way that suits you and is convenient for you. We're going to do that to this equation, and we're going to add 9 and subtract 9 and look at the benefits. Watch. Y equals x squared. I'm not going to combine any like terms. Watch. minus 6x plus 9. Okay, there's a plus 9. Minus 9 plus 11. I've been combining the like terms. Look at what this does. Look at this manipulation. If I add a 9 and subtract a 9, I haven't done anything to the equation because they cancel each other out. But look what I got. Look at this trinomial here. That's factorable now. And then the negative 9 and the 10, I can just combine. Watch what happens. Right, it becomes positive 2, huh? So y then is equal to, let's go and factor this trinomial in red. X minus 3, x minus 3, negative 9 plus 11 is a positive 2. And you can start seeing that it's going to start forming our vertex form. So y then is equal to x minus 3 squared plus 2, and we're done. Say again? Again, this is the new move here, adding and subtracting the same amount. It doesn't do anything in the equation. It's up to you. Some people will just want, you know what, I want to add 9 to the right side or the left side also, and then in the end subtract 9. You still get the same thing. It's a little logical move there. Right. So, what is the vertex here? We're actually done. The mission was just to write in vertex form, which we've done, because this is done. So, what would be the vertex here? Just out of curiosity. Good. Would it be negative 3 and 2 or 3 and 2? Right. Because look at here. Right, minus h, so the vertex is hk. This has to be a minus, this has to be a plus. And I think that's what we got. We got a minus and plus, so the vertex would be 3, 2. Let me verify real quick, but it is 3, 2. Let me type this in. Let me type in x squared minus 6x plus 11 on decimals. X squared minus 6x plus 11, so I'm just going to fix this part. Minus 6x. So there it is. Look at 3, 2. There's a vertex. 3, 2. All right. One more example. Example 3. Unless there's any questions for example 2. Number 3, let's get into vertex form. Okay. Y equals x squared plus 16x plus 14. Let's get this into vertex form. Y equals x squared plus 16x plus 14. Okay, so let's manipulate. Let's do some manipulation. Let's do some adjusting. Let's do some transforming here. A is 1, we're good to go. I'm going to get into examples when A is not 1 tomorrow because I don't want to give you nightmares yet. But it's just some more logical moves that are pretty ingenious. But let's just slowly get into that. So right now I'm just going to give you some examples of when A is 1. All right, so B over 2 squared. Here we go. B over 2 squared. Let me come off the side and calculate B over 2 squared. That's going to be 16 over 2 squared. That'll be 8 squared, 64. So I'm going to add 64 to both sides, or add and subtract on the right only. There's 2 options there. That's what I was trying to get out of this right up here. I can add B over 2 to both sides, or just add positive and negative B over 2 to the right side. Positive and negative, because they cancel each other out. Your choice. This is where you have options, whatever you feel more comfortable with. I'm going to go ahead and add it to both sides, the classic model from yesterday. But if you know the logic of what I was talking about from the previous example, knock yourself out. So here we go. Let me add 64 to both sides. Stay with me. So let's add 64 to the left. We'll add 64 to the right. Let's manipulate this. Here we go. We have y plus 64 equals x squared plus 16x. I'm not combining any like terms because I want to get a perfect square trinomial, a factorable trinomial, right? So now this trinomial is factorable right there because we got to be over 2 squared. So I have y plus 64 equaling x plus 8 times x plus 8. Remember, it's got to be the same binomial. And if it's not the same binomial, you did something wrong. So we have y plus 64 is x plus 8 squared plus 14. Question so far? Last step, what should I do? Subtract 64 from both sides. If we want to get y alone. So I have y equals x plus 8 squared plus a negative 50 or minus 50, either one is fine. I put the plus negative 50 because I want to stay consistent with the structure of the vertex form. In other words, vertex form is this: y is equal to a times x minus h squared plus k. So that's why I put the plus here. So I know that k is actually a negative 50. There's no doubt in my mind what k is. Now, look at over here. What is my h, though? Negative 8 or 8. That's where it gets tricky. This is x minus h. Right here I have x plus h. How can I make this a minus here? What do I do to manipulate this expression to make sure this is a minus something? But it would mean the same thing. Logically. Okay? Okay. But x plus negative 8 is not the same as x plus 8. See what I'm saying? How can I rewrite this expression but with the subtraction symbol there? But it will still mean the same expression. It will still mean x plus 8. Logically. How can I rewrite this? Hold up, I'll be right there. How can I rewrite this but with a minus, but still mean the same thing? Minus negative. One more time? That's what she said. Plus minus, that would be different. It would be x minus a negative 8. X minus a negative 8. Look at it. Right, because x minus negative 8 still means x plus 8. This means that, and that means that. So being faithful to the structure, look at the vertex is always HK. Look at HK when it looks like this. So H in this case is going to be negative 8. So the vertex will be negative 8, negative 50. That would be the vertex. Right. See, but it look. See, even though Avina got it right, the way he rewrote it, watch. Even though we can rewrite like this. Okay, we can rewrite it like this. It's actually bad manners to leave it this way. It's more professional to write it this way. But I did it this way so that you know in your head, when you have a plus, you can rewrite it like this so you know what H is. H is actually a negative in this case. Okay, it's a little tricky there. So this is This is bad manners, even though this is technically right. This is better manners. It's more elegant, more professional. More proper, more professional. There you go. All of that. All right, so let me just verify that that was a vertex. Y equals x squared. 16x plus what? Plus 14. All right, there's my graph. Look at this probably goes way down there. Let me see if the vertex was -8, 50, and there it is. -8, -50 is a vertex. Beautiful.